Now, class, let us continue the discussion on Maxwell's equations. So, saan tayo nag-end up last time? Recall natin yung apat na pinaka-important equations sa electrodynamics. Sa class, itong apat na to, mahalaga to. Una, yung Gauss law. Ang deadline ng problem set ay ano din, before the exam. So, bukas. So, delta T equals rho over epsilon naught. This is your Gauss law. Pangalawa, we have divergence ng magnetic field is 0. Walang pangalan. So, no name. Number 3 is the Faraday's law. Del cross E equals negative partial B partial T. And last, ano to? This is the Ampere's law. Yung corrected. So, yung kinorek na ni Maxwell, yung Ampere's law. Meron kang mu naught J plus mu naught epsilon naught partial E partial T. So, class itong apat na to, ito na. I think sa standard na electrodynamics class, enough na to for one semester. Itong hangganan na to, yung Maxwell's equations. Pero syempre 5 units tayo. No? So ano pa lang to? Medyo halfway. More than halfway pa lang ito nung coverage ng 130. So itong apat na to, standard, lagi niyo siyang maririnig na yung Maxwell's equations, yung gold standard sa electrodynamics kasi sobrang elegant nitong apat na to. Lahat mag-uumpisa dito sa apat na equations na to. Yung mga later on pag in-apply na natin siya sa mga problems. Ayan. Ma-appreciate nyo siya. Pero class, ito Maxwell's equations in free space, 'di ba? In matter naman, so in matter, syempre yung epsilon naught magiging epsilon. Tapos yung electric displacement, ay yung electric field magiging electric displacement, ganon. So in matter, ito lang yung form nila. Baka kasi makita nyo na yung iba sinasabi na ang Maxwell's equations ay ito. Pareho lang sila. Pinagkaiba lang, itong pangalawang version, in matter na. So una, divergence ng electric displacement is the enclosed free charges. Pangalawa, divergence of magnetic field is 0, hindi nagbago. Number 3, ganun pa rin. Del cross E, negative partial B partial T. So, hindi pa rin nagbabago yan. Ang ingay ng mga batang kalye sa labas. Number 4, narinig nyo ba sila? Narinig ko sila. Instead na magnetic field, yung auxiliary field, del cross H equals the free current JF plus partial D partial T. So, in vacuum or in free space, ito. Pero in matter, ito na yung Maxwell's equations. So, recall lang natin where D equals epsilon E. Tapos, yung auxiliary field natin, 1 over mu times B. Tapos, yung displacement current, JD, partial D, partial T. So, yan lang siya. Ito yung Maxwell's equations in free space. Ito yung Maxwell's equations in matter. Now, i-rewrite ko lang yung boundary conditions. Na-encounter na natin to before pero isulat ko lang ulit. So, boundary conditions for two different media. So, for two different media na separated by a boundary. So, for two different media separated by a boundary, meron tayong apat na boundary conditions. 1, epsilon 1, E1. So, kunwari, ito may medium 1 na epsilon 1, epsilon 2. Tapos, may mu 1, mu 2. Yan. So first boundary condition, epsilon 1 E1 perpendicular minus epsilon 2 E2 perpendicular component ng electric field, yan ay equal sa sigma F or the free surface charge density, free surface charge. So yung discontinuity ng electric field manggagaling sa surface charge density. Number 2, ang B1 perpendicular minus B2 perpendicular equals 0. Meaning the perpendicular component of the magnetic field is continuous. Walang discontinuity doon. So E1 parallel minus E2 parallel equals 0. So dito naman, yung parallel components ng electric field ay continuous. Kaya yung difference nila ay 0. And last, 1 over mu1, B1 parallel component minus 1 over mu2, B2 parallel component equals KF cross and hat. So, di ba dito yung discontinuity ng electric field galing sa surface charge? Dito naman yung discontinuity ng magnetic field galing sa surface current. So, yun yung boundary conditions natin. Hindi naman natin ito masyado gagamitin. So, sinulat ko lang. Okay, so nakapag-arrive na tayo. Bakit may fluids yan? Nakapag-arrive na tayo sa Maxwell's equations. Try natin siyang i-apply. So, mag-example tayo. So, first example, in a perfect conductor, the conductivity is infinite. So, yun yung ibig sabihin ng perfect conductor is infinite and the electric field is 0 inside. Kasi, the net charges, they reside on the surface. So, ganyan yung perfect conductor, di ba? So, ang problem 1, show that the magnetic field is constant inside a perfect conductor. So, dito class, medyo weird, no? Kasi electric field is 0 inside the conductor. Pero ang magnetic field ba 0 inside the conductor? So, papakita natin na not necessarily, pero constant siya. So, una, ano ba yung mga, ano natin dito, mga quantities na tinitignan? Electric field and magnetic field. Bale, yung Maxwell's equations, pwede siguro natin gamitin ito. Electric field, del cross E is negative partial B partial T. So, i-relate natin yung dalawa. So, use Faraday's law. So, here we have del cross E is negative partial B partial T. Class, di ba, ang electric field is 0 inside. So, del cross 0, 0 na to. Negative partial B partial T. So, ibig sabihin, B is independent of time. Kaya siya constant. Okay, class. So, ayun lang. Na-prove na natin na yung magnetic field natin, hindi constant siya in time. Not necessarily 0, pero some constant value siya. Kasi partial B partial T is 0. Okay, so that is the first question. Number 2, show that the magnetic flux through a perfectly conducting loop is constant. So, bali meron kang loop of wire dito, perfectly conducting. So, loop yan. Ang tanong, yung flux ba na nafe-feel niya ay constant? So, tignan natin class. Ang problem, magnetic flux. Pero sa Maxwell's equations, may makikita ba tayo magnetic flux? Di ba wala? Pero ito class ay mga differential form, ano? Meron tayong integral form pa ng Maxwell's equations. So, bale, ano ba yun? Isa-isahin ko ba? Wag na. Alam niyo naman na yung integral form ng Maxwell's equations. So, here, let us use Faraday's law. Use Faraday's law, integral form. Kasi class, yung integral form ng Faraday's law, dinadamay niya, kasali doon yung magnetic flux. So, bali, E dot dl equals negative d phi over dt. Ito yung Faraday's law in integral form. Now, inside the wire, syempre, inside dun sa wire, dun sa loop natin, E is 0. Kasi di ba perfectly conducting yan. So, yung wire natin, the electric field inside that is 0. Bale, E dot dl, yung left hand side natin, magiging 0 na yan automatic. Negative d phi over dt. So again, dahil 0 yung time derivative niya, the magnetic flux through the loop is constant or not changing in time. Kasi nga yung time derivative niya is 0. Okay, next question. Part pa rin, katuloy pa rin tanong kanina. So a superconductor, kanina perfect conductor, no? Ngayon naman meron tayong superconductor. Siya ay isang perfect conductor where the magnetic field inside is 0. Class, kanina 'di ba? Alam natin na ang magnetic field inside a conductor is constant pero not necessarily 0. So special case kung 0 siya, ang tawag doon superconductor. So ang tawag dito class ay Meissner effect. Yung ano, yung magnetic field inside is 0. Now ang tanong, show that the current in the superconductor is confined to the surface. Yun yung question. So, paano ba natin to masosolve? Pasahin natin yung problem. Magnetic field inside is 0, tapos may current. Tinatanong yung current kung anong value niya. So, ang gagamitin natin is the 4. Yun yung may current, di ba? Yung Ampere Maxwell. So, here we use Ampere Maxwell law. Ito yung del cross B equals mu naught J plus mu naught epsilon naught partial E partial T. Pero the magnetic field inside is 0 sa isang superconductor. Mu naught J plus mu naught epsilon naught. Class ng electric field sa loob ng conductor ay 0 din, di ba? So 0, mawawala yan. So J equals 0. Ano ibig sabihin nito? The volume bound current density is 0. Kaya, ano na lang yung currents na magfo-flow dun sa surface? Diba ang J ay volume bound current? So here, the volume current density. The volume current density is 0. Therefore, so then, the currents must reside at the surface. Yun yung sa superconductor natin. Okay, any questions, class? Si Bea, may tanong ba?
Wala po, sir.
Okay, si Kalista, Pauline.
None so far po.
Okay, wala naman. So kung walang tanong, let's look at another example. Ayan, puro tayo example ngayon sa Maxwell's equations. So example natin, for Faraday, induced electric fields. Class, ano bang Faraday induced electric fields? Yung may changing magnetic field. So yun, ang tawag doon, Faraday induced electric fields. Show that E equals negative partial A partial T. Ayan. Class, di ba yung Faraday's law, or rather, ayan, yung Faraday's law, pero kang change in magnetic flux. So paano ba nangyayari yon? Una, change in magnetic field or change in the geometry, di ba? So here, papakita natin na yung electric field dependent sa vector potential. Yung A yung vector potential ha, kung naalala nyo pa. Given by negative partial A partial T. So, ang problem natin dito, i-relate yung E at B. So, siguro magandang gamitin yung Maxwell equation 3, yung Faraday's law. So, recall, Faraday's law, del cross E equals negative partial B partial T. Pero class, ang B, di ba yan ay del cross A? Yung magnetic field natin, del cross A lang yan where A is the vector potential. So, bali ito, negative partial T ng del cross A. Pero class, ito spatial, ito temporal. Ito ay partial XYZ, ito ay partial T. Pwede nating i-interchange. So, meron tayong del cross E equals del cross negative partial A partial T. So, yung negative partial T, nilagay ko sa loob. Yung del cross, nilagay ko sa labas. Bale, makikita na natin dito by inspection, yung E, del cross E equals del cross something. Eh, yung something na yun ay negative partial A partial T. Therefore, E equals negative partial A partial T. So, ayan. Diba? Galing. Dali lang. So, meron na tayong relationship with ng electric field in terms of the vector potential. So, kung yung vector potential mo ay time dependent, time changing, mag-i-induce yan ng electric fields. Okay, number 2, katuloy nung question natin. So, spherical shell of radius R carries a uniform charge density sigma spinning at an angular speed omega. Angular speed omega. So, ang recall natin, class na encounter na natin itong problem na to, no? Yung A, the vector potential, kapag meron ka spinning spherical shell of radius R, surface charge density sigma, and it spins around angular speed omega, the vector potential is given by mu naught R omega sigma over 3 R sine theta phi hat inside. So, balikan nyo itong problem na to, class. Outside naman, mu naught r to the fourth omega sigma over 3 sine theta over r squared ano to? Phi hat outside. So, nirecall lang natin yan. Hindi pa yun yung tanong. So, yung vector potential ng system natin ganito. Tapos, ang nangyayari dun sa shell natin, the angular speed omega of t is time dependent. So, nagbabago siya sa function of time. Where d omega over dt is negative alpha, where alpha is some constant. So, bale yung spherical shell natin bumabagal kasi hindi omega over dt ay negative. So, bumabagal yung pag-ikot niya. The question, find the electric field. Inside and outside the sphere. Medyo ano to, no? Medyo weird. Kasi, yung magnetic field mo ay changing. Class, di ba, alam natin that changing magnetic fields cause electric fields. So, marami tayong source ng electric fields dito. So, bale, meron tayong two sources of electric field. Ang una is yung Coulomb. Class, di ba, kung meron kang charge, may electric field ka. Di ba, pangalawa, yung Faraday. Pangalawang source ng electric field ay Faraday. Ito yung changing magnetic fields cause electric fields. Ito, charges cause electric fields. Ito, changing magnetic fields cause electric fields. Sige, isa-isahin natin. Yung Coulomb, i-mental na lang natin na mag-Gauss law tayo. Inside, syempre yung charge mo inside ay 0. Wala kang charges enclosed. So, bale, pag nag-Gauss law ka, E0 inside the conduct, inside the shell. So, outside naman, ang enclosed charge mo ay yung total, no? So, yan ay kq over r squared lang. 1 over 4 pi epsilon naught. Ano yung total enclosed charge? Sigma 4 pi r squared over r squared, r hat. Or this is equal to sigma r squared over epsilon naught r squared, r hat. Yan yung electric field outside sa Coulomb. Sa ano yun dahil sa charges na nakastick dun sa shell. Tapos may pangalawang source pa tayo, yung Faraday. So for Faraday, recall natin ito. E is negative partial, A partial T. Ayan. Pero ano ba yung A natin? Meron tayong A inside at A outside. So i-time derivative lang natin yan. So E equals ano to? Ano bang time derivative nito? Constant, constant, constant. Ito independent of time. Spatial yan. Ito lang, which is d omega dt. Yan lang yung may time derivative, which is negative alpha. Tama ba? Ayan negative alpha. So, negative mu naught r alpha. Itong alpha d omega dt na yan Tapos sigma. Pero d omega dt ay negative alpha. So, twice pala yung negative. Negative alpha, tapos may negative ka pa dito. Ayan. Over 3, r sine theta, phi hat, inside. Tapos, yung outside naman, d omega dt lang din yan, negative alpha. So, bale, negative mu naught r to the fourth, negative alpha, so magpa-positive yan, sigma over 3 sine theta over r squared phi hat outside. Bali, ang total, syempre, Coulomb plus Faraday. So, the total electric field inside, so bali yan ay 0, di ba? Yung 0 yung Coulomb natin, plus mu naught r alpha sigma over 3 r sine theta phi hat. So, yan na yung electric field. Tanggalin ko na nga yung 0. So, ayan. So, ang total electric field outside naman, so bali yung Coulomb, sigma r squared over epsilon naught r squared r hat plus mu naught r to the fourth alpha sigma over 3 sine theta over r squared phi hat. So, kung mababansin natin class dito sa total electric field outside, meron ka ng r hat and phi hat component. So, electric field mo, hindi lang radial, kundi angular din. So, ayan na yung ating total electric field outside. So, ganun lang class kapag may changing changing vector potential. Ano yan? Automatic na may electric field na mapoproduce yan. Any questions from this example? Si Erin, may tanong ka ba? Wala. Walang response. Si Godwin, any questions?
Wala po, sir.
Okay, wala naman. So kung walang tanong, next example tayo. So another example. Here, meron tayong circular loop of radius r and resistance. Medyo weird no kasi yung radius na fixed, parang yung variable r. Kasi yung resistance natin, big R din. So naubusan na ng letter. Is in a perpendicular increasing magnetic field. Na may magnitude alpha t. Tapos ang direction niya out of the page. Bale, meron kang magnetic field na increasing as time goes on given by B equals alpha t out of the page. So, anong itsura niyan? Meron kang loop. Tapos, may resistance R. Tapos, may radius kang R. Tapos, meron siyang magnetic field na exposed siya sa magnetic field na out of the page. So, ganyan. Ganyan yung itsura niya. First question, what is the current in the loop? So, yun yung natin, first question. So, di ba, alam naman natin to sa Faraday's law of induction. So, ang induced EMF, negative d phi over dt. So, ito ay negative d dt. Ano yung phi natin? B times area. Alpha t pi r squared. So, bali, ang time derivative nito ay ito lang, no? Magiging negative alpha pi r squared siya. So, class, ano ang positive orientation natin? Ang positive ay out of the page and counterclockwise. Ayan. Class, since ang induced EMF natin ay negative, meaning ang induced current mo ay magiging clockwise. I is clockwise. Yan yung direction ng ating induced current. Pero wala pa yung value niya. No? Recall natin that E equals IR. So, bali ang I natin E over R. Bali, ito ay alpha pi R squared over R. Yan na yung value ng induced current natin. Ano ang direction niya? Clockwise. Kasi negative. Okay, so yan na yung ating first question. Second question. Now, if a voltmeter is attached as shown. Bale, meron, ito yung bilog. Tapos, teka lang Ito yung radius. Ito yung radius. Ito yung center. Bale, ito 90 degrees. Tapos, ito yung voltmeter nyo. Ay. Ito yung voltmeter nyo. So, nakakabit siya dyan sa position na yan. Let's say this is point P. This is point Q. So, ang tanong, what is the reading in the voltmeter? Ang weird, no? Ano yung potential difference across dito sa points na yan, P and Q? So, bale, i-orient lang natin. Gawin nating XY. XY to So, paano tayo makakakuha ng voltage? 'Di ba? Una ito yung induced EMF. Ayan, alpha pi r squared. Pero pwede rin nating gawin is teka lang. Ang pwede nating gawin ay bukod dito sa induced EMF na to, voltage din yan Pero hindi natin alam kung at what particular points siya yung potential difference na yon. Ito kasi specified from point P to point Q. So, ang gagawin natin, kukunin natin yung E.dl. Naalala nyo to, class. So, E.dl, ito yung voltage, di ba? E.dl yan. Negative d phi over dt. Ito yung integral form ng Faraday's law. So, using this, pwede nating makuha yung ano na to? Yung phi ay I should say yung electric field. So now, ang gagawin natin, class, kukuha tayo ng so ito yung natin, loop of wire. What we'll do is kukuha tayo ng ganito na may radius S. Kuha tayo ng isang Amperian loop na may radius S. Amperian loop. Yung natin, kung saan natin i-integrate yung electric field. So, bale yung DL ay 2 pi S. Plus yung electric field natin dito sa loob ay circumferential. So, tatama yan dito sa loop na to. So, E times 2 pi S, yan ay equal sa negative d dt ng phi, which is pi S squared. Ito yung area nung ating nung ating imaginary loop pi S squared times the magnetic field, alpha t. So, E2 pi S equals negative pi S squared alpha, or E equals negative alpha S over 2 phi hat. Kasi circumferential yung ating electric field. Bakit ba natin kinuha yung electric field na yan? Para makuha yung yung potential. Kasi mag-i-E.dl tayo. Balik, class, ang direction ng electric field natin ganito, di ba? Pag ganyan, pa phi hat. Pero itong phi hat natin, pwede natin yang expressed in terms of I and j. So note phi hat equals negative sine phi I hat plus cos phi j hat. So yan yung kanyang conversion. So ang ating electric field, ito ay magiging negative alpha s over 2 ano to? Negative sine phi I hat plus cos phi j hat. So pwede natin tong isulat as positive alpha over 2 s sine phi I hat minus s cos phi j hat. Bale, ano ba yung itsura nito? Plus ito yung s, ito yung phi. Ano ang s cos phi? Yan ay x. Di ba ang cosine phi ay x over s? So, bali ang s cos phi ay x. Ang s sin phi naman ay y. So, bali itong electric field natin can be written as alpha over 2 yi hat minus xj hat. So, yan yung ating electric field. So, next step, para makuha yung potential difference. So, next, V equals negative E dot dl. Ayan. So, from, ano ba yung bounds of integration natin? From P to Q. From P to Q. Ayan. So, class, balik tayo dun sa unang lesson natin. Kung ang ating line ay ito, yung line integral natin may path na ganito, ang DL mo along X lang. So, bali ang DL natin, dxi hat. Kaya ako kinonvert dito. Ayan. So, bali, di ba, class, naalala nyo, yung pag nag-evaluate ng line integral, dapat kino-convert mo into x lahat. May nakikita tayong y dito. So, bali, tignan nga natin yung problem. Dito na lang sa kabila. So, ito yung half. 45 degrees. Kasi ito yung half. Ayan. Yung half triangle na yan. Ni-redraw ko lang. So, ito, 45 degrees R. So, itong, ano ang cosine 45 degrees? 1 over square root of 2. Bali ito, R over square root of 2. Tapos, itong kabila din, R sine 45 degrees. Bale, R over square root of 2 din. Kasi ang sine 45 ay square root of 1 over square root of 2. Tapos, bali ang y natin, di ba, ito ay xy. Ang y natin, ito yung path. Take note, ito yung path. May R over square root of 2 ka dito. May R over square root ka din sa kabila. Tapos yung y natin constant lang. Y equals R over square root of 2. Kasi 'di ba, kung yung path mo ito, changing ang x pero ang y constant. Yung value niyan, R over square root of 2. Bali yung line integral natin, negative P to Q ng ano yung E dot dl natin, alpha over 2 yi hat minus xj hat dotted with dxi hat. So, bali ito, negative integral i hat lang yung matitira, no? Alpha over 2 r over square root of 2 dx. So, class, ang differential natin ay dx. Saan ba nagraran ng x mo? From 0 hanggang dito, which is dalawa ng dalawang r over square root of 2. Bale, 0 to 2r over square root of 2. Dalawa, di ba? Isang r over square root of 2, tapos isa pang r over square root of 2 yung trinavel ng path mo. So, ang total, 2r over square root of 2. Bali, ang ating v, the potential difference now is negative alpha over 2 r over square root of 2 times 2r over square root of 2. Kasi integral ng dx ay x lang. So here meron tayong v equals negative alpha r squared over 2. Yan na yung reading sa voltmeter mo. Pero kung binaliktad mo, di ba yung voltage, pag binaliktad mo, nagpa-positive lang. So at the higher voltage, the meter reads alpha r squared over 2. Yan na yung ano, yan na yung reading dun sa ating voltmeter. Medyo ano no, medyo nakakalito kasi bigla tayong nag-line integral. Pero kung voltage kasi ang pinag-uusapan, ayun, kailangan mag-E.dl. Kasi yung induced EMF class, di ba, yung induced EMF, sa buong bilog yun. Kung kukuha ka lang ng portion, hindi madaling makuha yung potential difference. Kaya ito yung ginagawa natin. Nag-E.dl tayo. Okay, any questions? Si Easy, may tanong ba?
Wala naman po, sir.
Okay, si Jessica.
Wala naman po, sir.
Sige, walang tanong. Let us look at another example. Kaya, class, yung electromagnetic theory, yung isa sa mga dinadaing ng mga estudyante and ng mga prof. Parang isa siya sa mga most hated na subjects kasi ang daming kailangang i-recall, yung mga math, 'di ba, kung ano-ano. Tapos ang dami pa niyang physics. Ang daming coordinate systems mong ginagawa, nag-shift ka from Cartesian to spherical, tapos magiging cylindrical. Maano siya, matrabaho siya. Pero fun naman siya kung iisipin nyo. Anyway, so another example tayo. 2 coils are wrapped around a cylindrical form such that the same flux passes through every turn. Passes through every turn of both coils. Bale, class, alam niyo yung solenoid, 'di ba isang wire lang 'yon na ni-wrap nyo sa cylinder? Dito, ang gagawin natin, kuha tayo ng dalawang wire. Anong itsura nun? Kunwari, meron kang isang wire dito. Ayan. Paikutin natin. Bale, ang itsura niya magiging ganito. So, yung isang wire, ganyan siya. Pupunta siya dito. Tapos, mag-ano yan. Yan. Tapos, dito. Ganyan. Yan yung isang wire natin. So, ang primary, tawag natin dito primary wire na merong N1 turns. So, bali, 1, 2, 3, 4. Meron siyang N1 turns. Tapos, sisingitan natin ng isang secondary wire. Ang itsura ng secondary wire, ito siya. Kunwari dito. Ayan. So, bale, ito yung second wire natin. Parang alternating sila nung first wire. So ito yung secondary wire na merong N2 turns. Okay, so ayan, solenoid na merong dalawang wires. Class, itong system natin na to, actually ito ay isang transformer. Ayan, yung primitive na model ng transformer, ito siya. Yung basic na configuration niya. Meron kang solenoid, pero instead na one wire, dalawang wires yung naka-wrap sa kanya. So the question, if the current ay in the primary wire. So yung primary wire mo ay source ng may current nag-flow sa kanya. So is changing. What is the induced EMF in the second coil? Ay, teka lang. Battery is running low. So what is the induced EMF in the secondary coil? Ayan. So ang transformer class, basically, kinokontrol mo yung voltage or yung induced EMF dun sa secondary coil mo using the primary coil. So ano ba yung relationship ng mga yon? Okay. So class, 'di ba? Pareho lang naman yung flux na nagfo-flow dun sa dalawang wire kasi same magnetic field lang naman nagfo-flow diyan sa bawat isa. Tapos same lang yung ano nila, size nila, 'di ba? Pareho lang silang nakarap din sa cylinder. So gagawin natin, we let phi b be the flux through a single loop of either coil. Kasi pareho lang naman yan. Pareho lang yung size nila, pareho lang yung magnetic field na nagpa-pass through them. So ang phi B1, dun sa first coil, meron kang total na N1 times the flux per coil. Ayan, yung total flux mo sa wire 1, number of turns times the flux per turn. So ayan. Ang total magnetic flux mo naman sa secondary wire, N2 times the flux per loop. Ayan. And take note that the induced EMF in coil 1, yan ay given by E1 equals negative d phi dt. Negative d dt ng phi B1. So yan ay negative N1 d phi B over dt. Kasi N1 constant lang yan. Pwede mong ilabas. So bali ang ating E1 over N1 equals negative d phi B over dt. Ayan. Doon naman tayo sa coil 2. The induced EMF in coil 2 is given by E2 negative d phi B2 over dt. Bali ito ano to? Negative d dt ng N2 phi B. Eh di ilabas ko lang yung N2. Negative N2 d phi B over dt. Bali, we can write this as E2 over N2. Yan ay equal sa negative d phi B over dt. So meron tayong expression na yan. Pero class, take note. Nung una, meron tayong negative d phi B over dt. Dito, meron tayong negative d phi B over dt. Ibig sabihin, this expression is equal to this expression. Yung E1 over N1 equals sa E2 over N2. Therefore, we have the following. E2 over N2. Or the induced EMF in coil 2 is N2 over N1 times the induced EMF in E1. So, ayun na class. Yung E2 natin depends on E1 by a factor N2 over N1. So, ibig sabihin neto, kung alam ko yung flux sa 1, kung alam ko yung anong flux, yung induced EMF sa 1, kaya ko nang i-control yung induced EMF ko sa 2. Ang gagawin ko lang, i-adjust ko yung number of coils sa 2. So, medyo ano siya, medyo madaya. Pero ito yung basic na mechanism ng transformer. I-adjust ko yung number of turns dun sa coil 2 para makuha ko yung desired na na number of na desired na induced EMF. Okay, class, may tanong ba sa example na to? Si Noel Denise, may tanong ba? Ay, wala daw. Si Peniel Iledan.
Wala po, sir.
Okay, walang tanong. So, kung walang tanong, class, let us move on. Ang next topic natin will be on electromagnetic waves. So, ito na class yung medyo kakaiba siya. Kasi yung electrostatics, magnetostatics, tapos Maxwell's equations. Ano siya, di ba? Electricity alone, magnetism alone. Tapos itong electromagnetic waves, try natin gamitin yung Maxwell's equations para ma-explore ang electromagnetic waves. So first, what is a wave? Ang wave class ay disturbance in a medium. Disturbance in a medium that propagates with a fixed shape. So meron siyang fixed na shape at constant velocity. So, class, yung itsura ng wave natin, ganito. Kunwari meron kang, alam niyo yung tali, kapag ginanon nyo, di ba para siyang, yung wave na yon nagpo-propagate as time goes on. Pero yung shape niya, nare-retain. Kunwari meron kang wave na pag ganito. Ayan. Let's say ito ay f of z, 0. So ito, zt axis tayo. Z and t. Tapos ito, magpo-propagate yan. Same shape. Ganito siya. Same shape. F of zt na siya. Ayan. Magiging ganyan yung itsura niya later on. At some time t. So ang wave natin, hindi nagbabago ng shape, pero nagpo-propagate siya. So recall lang natin, itong disturbances na to, yung waves natin, so these disturbances satisfy the wave equation. So ang wave equation natin, yan ay given by partial squared f over partial z squared equals 1 over v squared partial squared f partial t squared. Itong differential equation na to, class, dinedescribe niya ang isang wave phenomenon. So I think sa ano to? Mechanics? Sa mechanics ba to? Yung waves. Where v is the speed of propagation. Ayan. Tapos, class, yung general solution. So, The most general solution to the wave equation is the sum of the wave to the right and wave to the left. Kasi sometimes hindi naman palaging pa-right yung waves natin. Pwede rin naman siyang umatras. So yung f of zt natin, pwede siyang maging ma-express as some function of z minus vt, ito to the right, plus some function of z plus vt, ito yung to the left. So ano, later on explore pa natin tong mga to. Bakit z minus vt, bakit z plus vt? Pero in the meantime, ganyan yung form niya. So now, in 3 dimensions, ang ating wave equation is given by del squared f equals 1 over v squared partial squared f partial t squared. So bali yung partial z, ginawa lang nating del para ma-generalize in 3 dimensions. Ito, time lang naman to, di ba? So, stay put siya. So yan yung ating 3-dimensional na wave equation. Now, class, i-recall natin itong identity na to sa vector calculus. Del cross v, yan ay equal sa del dot v minus del squared v. Yan yung ating isang identity. Yung sa second derivative, di ba, del cross v, ito yung ano niya, yung curl of curl. Okay, now in vacuum, so in vacuum, recall that number 1, del dot E, yung Maxwell's equation natin, rho over epsilon naught. Number 2, del dot B equals 0. Number 3, del cross E equals negative partial B partial T. And last, del cross B equals mu naught J plus mu naught epsilon naught partial E partial T. So ito yung 4 na Maxwell's equations natin. Now, suppose there are no charges and currents. So bali ang mangyayari, del dot E is 0. Kasi yung rho mo, 0. Rho J equals 0. Wala kang charges, wala kang currents. Number 2, hindi magbabago. Del dot B is 0. So number 3, del cross E hindi rin magbabago. Negative partial B partial T. Number 4, del cross B, yung J mo 0. Mu naught epsilon naught partial E partial T. Now, meron na tayong Maxwell's equations ng walang rho and walang J. Now, let us take the curl of equation 3. Ito. So, del cross E, yan ay equal sa del cross negative partial B partial T. Ayan. Pero yung curl of curl, ito siya, di ba? So, i-rewrite lang natin. Del dot E minus del squared E equals yung time derivative at saka yung spatial derivative, pwede natin i-interchange. Magiging negative partial T ng del cross B. Itong right-hand side. Balik class, itong del dot E 0 in the absence of charges. Tapos yung del cross B natin, mu naught epsilon at partial E partial T. So, bali negative, negative, magpa-positive na lang both sides, del squared E equals partial T ng mu naught epsilon naught partial E partial T. So yung constants ilabas natin. Meron tayong del squared E equals mu naught epsilon naught. Bale, partial E partial T, tas i-partial T mo ulit. Bale, magiging partial squared T. Partial T squared na, di ba? Partial squared E, partial T squared. Now, notice natin, i-compare natin siya sa wave equation, three-dimensional, del squared F. Ayan, 1 over V squared, partial squared F, partial T squared. So now, ang mapapansin natin, class, yung 1 over V squared, yan yung speed of propagation. So the speed of propagation is given by 1 over V squared equals mu naught epsilon naught. Bali, ang V natin, 1 over square root of mu naught epsilon naught. May value to. 1 over square root of yung mu naught, 1.2566 times 10 to the negative 6 meter kilogram per second squared ampere squared. Yan yung mu naught. Yung epsilon naught naman, 8.85 times 10 to the negative 12 second to the fourth ampere squared per meter cube kilogram. So, yan yung epsilon naught. Now, kapag kinalculator natin to, this is equal to 2.99 times 10 to the 8 meters per second. Or close to 3. So, 3 times 10 to the 8 meters per second. Now, ito yung speed of propagation ng ating, nung E. So, inote natin na yung V ay, ayan. Paano naman yung B? So, now, how about B? Kanina, tinake natin yung curl ng equation 3. This time, i-take naman natin yung curl ng equation 4. Now, take the curl of equation 4. So, magkakaroon tayo ng del cross B. Yan ay equal sa, ano to? Mu naught epsilon naught del cross, ay, ano ba to? Teka lang. So, del cross mu naught epsilon naught partially partial T. Partial E, partial T. Ayan. So, bale, ito del dot B minus del squared B. Yun yung curl of curl. Pero yung right hand side, mu naught, yung mu naught epsilon naught, pwede kong ilabas. Tapos again, ito temporal, ito spatial, pwede nating interchange. Partial T ng del cross E. Ayan. So, bali, ang del dot B natin from Maxwell's equations, 0 yan all the time. Meron tayong negative del squared B equals mu naught epsilon naught partial T ng, ano yung del cross E? Negative partial B partial T. Bale, negative del squared B equals mu naught epsilon naught negative. Tapos ito, dalawang beses mo ito time derivative yung B. Ayan, partial squared B, partial T squared. Yung negative, gawin na nga nating positive both sides. So, in-write ko nga lang. Del squared B equals mu naught epsilon naught partial squared B partial T squared. Gagawin natin, i-compare ulit natin sa wave equation. So, compare. Del squared F equals 1 over V squared partial squared F partial T squared. And therefore, yung speed of propagation again yung magnetic field natin, speed of propagation is 1 over v squared equals mu naught epsilon naught. Or v is 1 over square root of mu naught epsilon naught. So ang v natin, 3 times 10 to the 8 ulit. Katulad nung kanina. Ito. Meters per second. So ito ulit yung speed of propagation nung ating wave. Pero class, ang interesting na coincidence. So however, the speed of light. So the speed of light in vacuum, this is also given by C, yan ay 3 times 10 to the 8 meters per second. So bali class, ang conclusion natin that light is an electromagnetic wave. Kasi ito yung velocity ng yung speed of propagation ng electromagnetic wave natin. So therefore, yung light dapat siya rin yun. Light is an electromagnetic wave. So ating conclusion, light is an electromagnetic wave. So alam niyo na siguro to, no? Pero nung panahon nila Maxwell, big discovery. Kasi dati electricity ay different topic, magnetism is different topic. Tapos nung nagkaroon ng Faraday's law, somehow na-merge yung dalawa. Pero ngayon, sumali na yung optics, yung light. Ang light pala ay isang electromagnetic wave. So magkaka-connect yan sila, class. From electricity to magnetism, Maxwell's equations, hanggang sa electromagnetic waves or light. So ito yung dito nalaman yung theoretical na speed ng light, 1 over square root of mu naught epsilon naught. Saan ba nanggaling itong mga constants na to? Di ba experimental tong mga to? Sa electrostatics and magnetostatics yan galing eh. So nung panahon na yon, di ba, who would have thought na ito pala yung mga constants na magdidictate kung ano yung speed ng light, yung speed ng electromagnetic wave, which is 3 times 10 to the 8 meters per second.